Maybe you have heard about the ozone layer, but do you know how important it is for survival? And are you conscious that we're destroying it? But first, what is exactly the ozone layer?
The ozone layer is an invisible layer made of ozone, a molecule of three oxygen atoms. It's located in the stratosphere, between 15 and 30 kilometers above the Earth's surface. The ozone layer has the capacity to absorb approximately 98% of ultraviolet radiation that comes from the sun, which is harmful for humans and animals. It acts as a protective shield for life on Earth. This layer is constantly repaired and destroyed, but there are some compounds that can make this layer difficult to repair. What are these compounds? These chemical compounds are called chlorofluorocarbons, or CFCs. CFCs are simple organic compounds that contain the element carbon, chlorine, or fluorine. In this slide, you can see the CFC11, which is one of the most produced, but there are others, like these ones: CFC12, CFC113, CFC114, and CFC115. They have different structures, but all of them damage the ozone layer. And what are they used for? Businesses and consumers use them because they are inexpensive. They don't catch fire easily, and they don't usually poison living things. So CFCs were and are used, for example, as refrigerants, as solvents in the electronic industry, as aerosol propellants, in fire extinguishers, as dry cleaning solvents, as degreasing agents, and in foam packing and insulation materials. Relationship between the amount of atmospheric CFCs and the depletion of the ozone layer. And how do these compounds damage the ozone layer? When different objects emit CFCs, these ones go to the ozone layer. Then UV radiation hits the CFC molecule. A chlorine atom is ejected from the molecule. When this free chlorine atom comes into contact with ozone in the stratosphere, it destroys the ozone molecule. First, the free chlorine atom hits an ozone molecule. From this molecule, an oxygen atom is released and bonds with chlorine. Then, a free oxygen atom hits the chlorine monoxide molecule, and two oxygens will be unified while the chlorine will be ejected, and therefore another free chlorine atom will be ready to continue interacting with another ozone molecule.
One single chlorine atom can destroy over 100,000 ozone molecules before it is removed from the stratosphere. This type of destruction is what is called the ozone depletion. The ozone depletion occurs all over the Earth. However, this phenomenon is more pronounced, for example, in Antarctica than in the Arctic because of two main phenomena. The first one, the circulation of winds in the stratosphere that transport the CFCs toward these polar latitudes where they accumulate. And the second one, the formation of the ozone hole, is also directly linked to the stratosphere's temperature. Once temperatures drop below -78 degrees, polar stratospheric clouds tend to form, which increases ozone depletion. For this reason, an ozone hole is formed in Antarctica. It's not a hole, it's a part of the ozone layer that has little amount of ozone molecules. In 1988, other countries in the world agreed the Montreal Protocol to regulate the production of CFCs in order to not damage the ozone layer. Relationship between the rise of skin cancer cases in southern countries and the amount of CFCs in the atmosphere. What are the consequences of having such a high concentration of CFCs in the atmosphere? In this graph, we can see the increase of CFC concentration in pptV part per trillion in the Earth's atmosphere from 1940 to 2010. Because of this increase in CFC's concentration, ozone layer is decreasing, so more UV radiation is able to penetrate through the Earth's atmosphere. When this UV radiation comes in contact with human skin, melanoma can appear, the cancer of the skin. This increase of melanoma cases are very pronounced in countries near the ozone hole such as Australia. As you can see in the graph, the blue line that indicates the amount of cases diagnosed with melanoma in percentage is increasing along years, and in orange are represented the deaths in percentage. Here we can see a comparison of melanoma cases in different countries. We can clearly see that the most affected countries are the ones that are located near the ozone hole. Finally, we are going to see how the ozone layer is currently recovering. Thanks to the Montreal Protocol, the use of CCCs is decreasing, so less chlorine was expelled to the atmosphere and therefore less ozone molecules are destroyed. NASA, in this graphic, shows a prediction of how ozone is expected to evolve. We can conclude that levels of ozone before 2070 are projected to reach pre-1980. For this reason, we should continue protecting this important layer because, if not, we will not be able to revert the current situation.